What if I told you that the universe is not just a silent expanse of stars, but a stage where some of the most extraordinary events are about to unfold? Imagine a realm where stars explode with the brightness of a billion suns, rogue planets wander aimlessly through the void, and celestial alignments create spectacles that defy imagination. These aren't scenes from a science fiction story. They are actual cosmic phenomena predicted to occur in the not-so-distant future. The universe is vast beyond comprehension, filled with mysteries we have only begun to unravel. By studying subtle shifts in light, gravitational waves, and even faint radio signals from the depths of space, scientists have decoded a fascinating schedule of upcoming events that will leave you in awe. From breathtaking supernova explosions to the detection of distant, Earth-like exoplanets, each prediction is a puzzle piece to understanding our place in the cosmos. Stay with us as we embark on this journey through the unimaginable, exploring 25 cosmic events that promise to reshape the way we see and experience the universe. Prepare to be amazed, because what lies ahead is nothing short of spectacular. With the first cosmic event in our journey, we turn our attention to the ever-energetic Sun and the looming possibility of a solar superstorm. Imagine a massive burst of energy from the Sun, known as a solar flare, ejecting a cloud of charged particles toward Earth at astonishing speeds. While this may sound like the plot of a science fiction movie, scientists warn that such an event is not merely possible, it is inevitable. The last time the Earth experienced a solar storm of this magnitude was in the year 1859, during what became known as the Carrington event. This powerful geomagnetic storm disrupted telegraph systems worldwide, causing some to spark and even catch fire. Now, consider how reliant our modern world is on satellites, global positioning systems, and electrical grids. A superstorm today could send shockwaves through communication networks, disrupt aviation, and cause widespread power outages, potentially plunging entire regions into darkness for weeks. Fortunately, we are much better prepared than we were over 160 years ago. Scientists now use advanced tools like solar observatories and spacecraft, including the Solar and Heliospheric Observatory and the Parker Solar Probe, to continuously monitor the Sun's activity. These instruments allow experts to detect and analyze solar flares early, providing critical warnings to protect vulnerable systems on Earth. As we marvel at the Sun's brilliance, we must also respect its immense power and unpredictability. Stay tuned as we explore the next fascinating cosmic event, one that underscores the delicate balance between the Earth and the heavens. Now turning to the next celestial phenomenon, we focus on a tense and awe-inspiring scenario: the predicted near-misses of asteroids passing uncomfortably close to Earth. Among these, one name stands out: Apophis, a space rock roughly the size of 3 football fields, hurtling through the cosmos. This particular asteroid is set to approach our planet in the year 2029, coming closer than some of our own satellites. Imagine looking up at the night sky and being able to spot a cosmic visitor with the naked eye. While the very thought of such an event can send chills down the spine, scientists assure us that Apophis poses no immediate danger of impact during this flyby. But how do researchers calculate these risks with such precision? The answer lies in the incredible advancements in astronomy and planetary defense. Observatories worldwide use powerful telescopes and radar imaging to track the paths of near-Earth objects with meticulous detail. Organizations like NASA, a Planetary Defense Coordination Office, continuously analyze data, studying factors such as an asteroid's trajectory, size, and velocity to determine its exact likelihood of collision with Earth. This monitoring has become a crucial part of safeguarding our planet against potential threats. One fascinating aspect of Apophis's approach is the unique opportunity it provides for scientific observation. Its close pass will allow astronomers to study its composition, spin, and surface in unparalleled detail. Such data could deepen our understanding of these wandering space travelers and even aid in designing future missions to alter the path of any hazardous asteroids. While the thought of an asteroid impact may stir anxiety, it is also a reminder of humanity's ingenuity and the vigilant watch we keep over the skies. As we continue our cosmic journey, let us uncover a rare planetary alignment that promises to delight stargazers and ignite our sense of wonder. With the next spectacular event shimmering on the horizon, we turn our attention to a cosmic dance that has fascinated humanity for centuries: the rare alignment of Jupiter and Saturn, known as the Great Conjunction. This celestial phenomenon occurs when these two giant planets come so close in the sky that, to the naked eye, they appear almost as a single, brilliant point of light. While Jupiter and Saturn align approximately every 20 years, the upcoming conjunction is particularly special due to its extraordinary proximity, a level of closeness not seen in nearly 4 centuries. Imagine stepping outside on a crisp, clear evening and witnessing the two largest planets in our solar system sharing a luminous embrace against the backdrop of stars. It's an awe-inspiring sight that has captured the imagination of skywatchers throughout history. In fact, some even speculate that a great conjunction like this might have been the inspiration for the Star of Bethlehem described in historical and religious texts. Whether or not that's true, the rarity of such alignments makes them a significant event not just for casual observers but also for astronomers. Scientifically, the Great Conjunction is a moment of immense interest. As Jupiter and Saturn align relative to Earth, their combined gravitational forces and positions offer a valuable opportunity to study planetary motion and dynamics on a grand scale. Moreover, this event allows astronomers to refine their understanding of orbital mechanics, an area that is critical for everything from space exploration to satellite positioning. Beyond the science, the sheer beauty of this astronomical occurrence unites people around the world, reminding us of the vast and interconnected universe we inhabit. But what makes this event even more accessible is that it requires no advanced equipment to enjoy. With a simple glance skyward, anyone can take part in this celestial spectacle. Those with telescopes, however, will be treated to an even more detailed view, with both planets and some of their moons fitting into the same field of vision. It's a chance to connect with the cosmos in a way that feels both intimate and humbling. As this once-in-a-lifetime moment approaches, make sure to mark your calendar and find the perfect spot away from city lights to fully embrace the wonder of the Great Conjunction. And as we continue to marvel at the heavens, let's move forward to an event showcasing the raw, explosive power of the universe's most energetic occurrences. Now stepping into the realm of sheer cosmic power, let's explore an event that showcases the universe's most extreme and energetic explosions, a gamma-ray burst. These bursts are intense flashes of gamma-ray light, the highest energy form of radiation, and they originate from catastrophic cosmic events such as the collapse of massive stars or the merging of neutron stars. Lasting anywhere from a fraction of a second to several minutes, these bursts release more energy in that short span of time than our Sun will produce over its entire lifetime. Just imagine such incomprehensible power unleashed in a blink. Predictions about detectable gamma-ray bursts in the near future are stirring excitement among astronomers. With the increasing sensitivity of modern space observatories, scientists are poised to catch more of these fleeting, distant explosions than ever before. By studying them, researchers can gain deeper insights into the life cycles of stars, the formation of black holes, and even the distribution of matter in the universe. The data collected from gamma-ray bursts can also provide clues about the early stages of our cosmos, as some of the detected bursts have traveled billions of years to reach us, essentially serving as snapshots of a younger universe. But what would happen if a gamma-ray burst occurred within our galactic neighborhood? While such an event is astronomically unlikely, the implications could be significant. A nearby burst directed toward Earth could pose a serious threat to our atmosphere. The gamma rays could deplete the ozone layer, exposing the surface to harmful ultraviolet radiation from the sun and potentially disrupting ecosystems and agriculture. Historical theories even suggest that a gamma-ray burst might have contributed to past mass extinctions on Earth, though this remains a topic of ongoing research. Despite these hypothetical risks, detecting and studying gamma-ray bursts is not just about understanding their destructive potential. These phenomena are also cosmic laboratories that help us unlock fundamental truths about the universe. By observing them, scientists can refine their models of extreme physics and push the boundaries of human knowledge. As this era of exploration continues, equipped with advanced telescopes and detection systems, we stand at the forefront of uncovering the mysteries behind these awe-inspiring explosions. Moving forward, our journey through the universe's wonders brings us to an entirely different kind of discovery, one that challenges the very idea of what defines a planet. Now shifting our gaze to a phenomenon that defies the norms of planetary existence, let's delve into the fascinating mystery of rogue planets. These elusive worlds drift through the cosmos completely untethered to any star. Unlike the planets in our solar system which faithfully orbit the sun, rogue planets are cosmic loners, wandering the vast expanse of space on their own. But how do these celestial runaways come to be? Scientists believe rogue planets are often ejected from their original star systems due to gravitational upheavals. Imagine the chaos of planetary systems forming, with young, massive planets disrupting each other's orbits until some are cast out into the void, destined to roam the galaxy alone. What makes the discovery of a rogue planet so intriguing is the sheer challenge involved in finding one. Without a parent star illuminating their presence, these planets are incredibly difficult to detect. However, astronomers are optimistic that advancements in infrared telescopes and gravitational lensing techniques will soon lead to breakthroughs. Infrared technology allows us to detect the faint heat signatures emitted by these otherwise invisible objects, while gravitational lensing, a method that relies on the warping of light by massive objects, can reveal their location when they pass in front of a distant star. Spotting a rogue planet is not just about tracking a cosmic curiosity. It's also about uncovering clues to the complex dynamics of planetary systems. Each rogue planet discovered tells a story about its past, how it formed, the forces that ejected it, and what it has endured during its solitary journey. Some might even carry frozen oceans or hidden atmospheres, sparking fascinating questions about their ability to harbor life in such extreme isolation. Could a rogue planet with a thick atmosphere of greenhouse gases retain enough warmth to sustain microbial life, even without a star? The possibility, while far-fetched, is enough to ignite the imagination. As space exploration technology advances, the likelihood of finding rogue planets within our galactic neighborhood grows ever stronger. With each discovery, we take another step toward understanding these solitary wanderers and how they fit into the grand puzzle of the universe. And as we continue this thrilling expedition, let's turn our attention to yet another awe-inspiring phenomenon, a supernova explosion that could light up the night sky. With the next chapter in our cosmic journey unfolding, let's dive into one of the most breathtaking spectacles the universe has to offer, the explosion of a supernova. Imagine a star reaching the end of its life in a grand finale so powerful that it outshines entire galaxies for weeks. While such events are incredibly rare on a human timescale, astronomers believe there's a chance we may witness one in our lifetime. One star that has captured the world's attention is Betelgeuse, the red supergiant in the constellation of Orion. This stellar giant has been showing signs of instability, with its brightness dimming and fluctuating in ways that hint it may be nearing the end of its life. However, in the cosmic timeline, soon could mean anytime from tomorrow to the next few 100,000 years. If Betelgeuse were to go supernova, the explosion would be so bright that it could be visible even during the day, transforming our night skies into an otherworldly scene of light and wonder. But what exactly happens during a supernova? At its core, the event marks the catastrophic collapse of a massive star. When the fuel that powers nuclear fusion runs out, the star can no longer support its own weight, causing its core to implode in a fraction of a second. This triggers a violent explosion that hurls stellar material into space at astonishing speeds. The result is not just a visual spectacle, but also a cosmic phenomenon of immense scientific value. The debris from a supernova includes elements like iron, gold, and even uranium, materials that are essential to the formation of planets and life itself. In fact, much of the matter that makes up Earth and even our own bodies was forged in the hearts of ancient stars and scattered through space by these colossal explosions. For astronomers, observing a supernova in real time would be a once-in-a-lifetime opportunity to gather critical data. Advanced telescopes and space observatories are now better equipped than ever to capture these events, allowing scientists to study the origins of heavy elements, the mechanics of stellar death, and the mysterious remnants left behind, such as neutron stars or black holes. And beyond the science, a supernova visible from Earth would be a profound reminder of our connection to the universe, a glimpse into the powerful forces that shaped everything we know and are. As we await the possibility of witnessing such an extraordinary event, let's continue exploring the cosmic stage. Coming up next, we'll uncover the mysteries of merging black holes, a process so extreme it generates ripples in the very fabric of space and time. As the next phase of the journey comes into focus, we venture into the awe-inspiring realm of merging black holes, a cosmic ballet where the most mysterious objects in the universe collide. Picture two black holes spiraling closer and closer together, their immense gravitational forces drawing them into an inevitable and monumental union. When these titans of space finally merge, the event releases an extraordinary burst of energy, sending ripples through the fabric of space and time itself. These ripples, known as gravitational waves, were first detected by scientists just a few years ago, marking one of the greatest breakthroughs in modern astrophysics. Gravitational waves are essentially cosmic vibrations, much like the ripples created when a pebble is dropped into a pond, except these waves distort the very structure of space and time. Detecting them requires instruments of incredible precision, such as the advanced observatories on Earth that can measure distortions smaller than the width of an atom. Since the first discovery of gravitational waves, scientists have continued to monitor the universe for signals of black holes merging, and they predict there are many more events waiting to be captured in the galaxies around us. What makes these mergers so significant is not just the sheer power they unleash, but the insights they provide into some of the universe's most extreme conditions. By studying the frequency and characteristics of gravitational waves, scientists can uncover details about the masses, spin rates, and even potential origins of these black holes. If two black holes were once part of a binary star system, their collision could reveal secrets about the life cycles of massive stars. And that is not all. These events also help refine our understanding of fundamental physics, offering a testing ground for Einstein's theories under conditions no laboratory on Earth could replicate. Perhaps most fascinating is the idea that these black hole mergers could hold clues about the early universe. Some black holes are believed to have formed just after the Big Bang, meaning their collisions might carry echoes of the very first moments of our cosmos. Each detection adds another piece to the puzzle of how galaxies evolve and how matter is distributed across the vast expanse of space. As we wait for the next gravitational wave to send its signal across the cosmos, let's turn our gaze to another fascinating phenomenon. Up next, we'll explore the incredible shifts in Earth's magnetosphere and the cosmic forces that could one day alter our planet's magnetic shield. With the next phase of the journey in sight, let us turn our attention to a remarkable but concerning phenomenon, the shifting of Earth's magnetosphere. The magnetosphere is our planet's invisible shield, a protective bubble of magnetic energy that deflects harmful solar winds and cosmic radiation. Without it, life on Earth as we know it would be vulnerable to these intense cosmic forces. However, scientists have observed signs that this magnetic shield is not as stable as it might seem. Over the past centuries, the magnetic field has been slowly weakening, and historical records suggest that the north and south magnetic poles, have flipped many times in the planet's history, an occurrence referred to as a magnetic reversal. If such a reversal were to happen again, the effects could be profound. Navigation systems that rely on the magnetic field, such as compasses and even certain technologies in airplanes and ships, would face significant disruptions. On a more biological level, many species, including migratory birds, sea turtles, and even some insects, depend on Earth's magnetic field for navigation. A sudden or extreme shift could leave these creatures disoriented, potentially altering ecosystems and food chains. For humans, the weakening of this shield could expose us to higher levels of radiation. This might heighten risks for astronauts and passengers on high-altitude flights, and could even increase the rates of certain illnesses. One of the driving forces behind such shifts could be the Sun itself. Solar winds, streams of charged particles emitted by the Sun, exert constant pressure on the magnetosphere. During periods of heightened solar activity, powerful solar storms can compress this field, even causing temporary breaches. Such cosmic interactions could exacerbate the weakening of Earth's magnetic field, potentially accelerating the timeline for a reversal. Scientists are using advanced models and monitoring techniques to better understand how these cosmic forces and the inner dynamics of Earth contribute to the magnetosphere's behavior. While predictions about when or if a reversal could occur remain uncertain, it is clear that any significant change in this magnetic shield could have far-reaching consequences for life on Earth. As we ponder the fragility of this protective barrier, our journey takes us next to another celestial event that captures the imagination: the appearance of brilliant comets and the stories they bring from the earliest days of the solar system. Turning our gaze to the celestial wanderers of the cosmos, comets stand as some of the most enchanting and mysterious visitors to our skies. These icy bodies, often described as snowballs of gas, rock, and dust, originate from the farthest reaches of the solar system, such as the Kuiper Belt or the even more distant Oort cloud. Predictions suggest that in the near future, new comets may be discovered, with some potentially making spectacularly close passes by Earth, offering both awe-inspiring sights and invaluable opportunities for scientific study. But how do astronomers identify these elusive objects? Advances in telescope technology and sky survey programs have allowed scientists to detect faint glimmers of light far beyond the planets, tracing the orbits of these icy travelers as they journey toward the warmth of the Sun. As a comet approaches, solar radiation begins to vaporize its icy surface, creating the iconic glowing coma and trailing tails of dust and gas that make these objects so visually stunning. Historically, comets have fascinated and sometimes terrified humanity. In ancient cultures, they were often seen as omens, their sudden and dramatic appearances linked to significant events like wars, the rise and fall of empires, or natural disasters. Yet comets hold far more than symbolic meaning. They serve as time capsules from the formation of the solar system billions of years ago. Within their icy cores lie clues about the primordial materials that gave rise to the planets and potentially life itself. Modern space missions, such as those that have collected samples from comets, reveal a wealth of information about the chemical composition and physical properties of these ancient bodies. For instance, some comets contain organic compounds, sparking discussions among scientists about their possible role in seeding early Earth with the building blocks of life. In the coming years, newly discovered comets could offer scientists fresh opportunities to analyze these cosmic relics. By studying the trajectory, composition, and the intricate interplay of a comet with solar radiation, researchers can deepen our understanding of both the origins of our solar system and the dynamic forces that continue to shape it. For skywatchers, these appearances are nothing short of magical, a moment to pause and reflect on the vastness of the universe and the fleeting beauty of these celestial visitors. As we prepare for these dazzling sights, let us now turn to another cosmic event with immense scientific and visual appeal: discoveries of exoplanets that may hold the secrets to life beyond Earth. Shifting our focus to the uncharted territories beyond our solar system, the search for exoplanets, worlds orbiting stars other than our Sun, has entered a groundbreaking era. Thanks to advancements in telescope technology, astronomers are now able to peer deeper into the cosmos, detecting planets that were once hidden from our view. These discoveries are not just about finding new planets, but about uncovering Earth-like worlds that might harbor the conditions necessary for life. When searching for habitable planets, scientists focus on a crucial zone often referred to as the Goldilocks zone. This is the sweet spot around a star where conditions are neither too hot nor too cold, allowing liquid water to exist, a key ingredient for life as we know it. But water is only part of the equation. Researchers also analyze a planet's size, atmosphere, and distance from its star, seeking vital clues that could indicate its potential to support biological processes. The recent progress in this field has been astonishing. Space observatories like the Kepler Space Telescope and its successor missions have already identified thousands of exoplanets, with a fair number falling within the habitable zone of their respective stars. But the future holds even greater promise. With the development of next-generation instruments like the James Webb Space Telescope and upcoming ground-based observatories, scientists expect to not only find more exoplanets but also analyze their atmospheres in unprecedented detail. By examining the light that filters through a planet's atmosphere during its transit across its star, astronomers can detect signatures of gases like oxygen, carbon dioxide, and methane, which might hint at biological activity. The implications of such findings stretch far beyond scientific curiosity. The discovery of even a single world with signs of life would fundamentally alter our understanding of our place in the universe, providing the most profound evidence yet that Earth is not unique in its capacity to foster life. Beyond the science, the idea of discovering another Earth captures the imagination of people everywhere. Could we one day not only observe such a planet but even visit it? While interstellar travel remains a distant dream, every exoplanet discovery brings us one step closer to unraveling the mysteries of the cosmos and answering the age-old question, are we alone? As these incredible technological advancements continue to open new windows into the universe, let us now turn our gaze to a neighboring galaxy and explore the cosmic ballet that may one day transform our view of the night sky, the steady approach of the Andromeda Galaxy. Now shifting our attention to a grand cosmic rendezvous blazing on the distant horizon, the Andromeda Galaxy's slow but inevitable approach toward our Milky Way stands as one of the universe's most extraordinary predictions. Although this celestial event is expected to unfold billions of years in the future, the initial signs of this galactic dance are already visible to astronomers. The Andromeda Galaxy, located over 2 million light-years away, is hurtling toward us at a staggering speed of around 70 miles per second. While this might sound alarmingly fast in the vastness of space, the collision is proceeding in what can only be described as a slow-motion ballet, giving scientists ample time to study and model its pathway. But how do astronomers make sense of such an immense and distant event? The key lies in detailed observations of Andromeda's motion relative to our own galaxy. By using cutting-edge tools such as the Hubble Space Telescope, scientists have been able to measure the galaxy's speed and direction with incredible precision. What they have discovered is awe-inspiring. Gravity, the invisible architect of the cosmos, is pulling the two galaxies together, setting the stage for an eventual merger. Although this might sound catastrophic, the merging process will likely be more of a transformation than a violent collision. The sheer distances between individual stars mean that direct impacts will be rare, but the gravitational forces at play will reshape both galaxies into a new, larger elliptical galaxy, sometimes referred to as Milkomda by scientists. Even more fascinating is how astronomers anticipate earlier observable changes in Andromeda's trajectory. As the galaxy draws closer, its light will appear to shift due to the Doppler effect, and its position in the night sky will subtly change over countless generations. Eventually, future inhabitants of Earth, or humanity's descendants elsewhere in the cosmos, may witness the Andromeda galaxy growing ever larger in their sky, offering a visual spectacle that would be both humbling and breathtaking. But for now, telescopes on Earth and in space track this cosmic waltz, providing vital insights into galactic evolution and the profound interconnectedness of the universe. What makes this event even more astonishing is the sheer opportunity it provides for scientific discovery. By studying Andromeda's approach and its eventual interaction with the Milky Way, astronomers can better understand how galaxies evolve, merge, and create new structures over time. These cosmic unions are thought to play a key role in the life cycle of galaxies, influencing star formation, black hole activity, and even the future environments where life could potentially emerge. While the collision is billions of years away, the predictions and knowledge gained today deepen our appreciation for the intricate choreography of the cosmos. With that awe-inspiring thought, let us shift our gaze to another phenomenon, one that emanates from the very heart of the universe itself, the enigmatic bursts of energy known as cosmic radiation. With the next chapter of our cosmic exploration unfolding, let us delve into a phenomenon that showcases the raw intensity of space itself, a predicted spike in cosmic radiation. This invisible yet powerful radiation originates from energetic particles streaming through space, often accelerated by solar activity or dramatic interstellar events such as supernova. While the vacuum of space might seem calm and empty to the naked eye, it is, in reality, brimming with these high-energy particles traveling at nearly the speed of light. But what exactly does this mean for us here on Earth and for those venturing beyond our home planet? For astronauts, the stakes could not be higher. Outside the protective shield of Earth's magnetic field, their bodies are directly exposed to increased cosmic radiation. This exposure poses serious risks, ranging from short-term effects like nausea and fatigue to long-term health consequences, including an elevated risk of cancer. It is a challenge that has become even more pressing as humanity sets its sights on long-term missions to the Moon, Mars, and beyond. Space agencies worldwide are racing to develop advanced shielding materials and medicines to mitigate these threats, ensuring that the bold aspirations of space exploration can be safely pursued. Closer to home, a spike in cosmic radiation could also disrupt the technology we depend on every day. Satellites orbiting Earth are especially vulnerable, as their sensitive electronics can be damaged or even disabled by a sudden surge of energetic particles. A widespread rise in radiation could impair communication networks, navigation systems, and Earth monitoring technologies, which are critical for everything from weather forecasting to global internet services. Even power grids on the ground are not immune, as increased radiation could induce currents in long electrical systems, potentially leading to widespread outages in extreme cases. Adding to the intrigue, cosmic radiation spikes serve as a natural laboratory for scientists to study the universe. By examining these energetic particles, researchers can gain deeper insights into the most extreme events in the cosmos, such as the explosions of dying stars or the mysterious outbursts from black holes. Each particle that reaches us carries a story, a snapshot of the violent processes shaping distant corners of the universe. In this way, even the challenges posed by cosmic radiation contribute to our understanding of the broader cosmic tapestry. What's remarkable is how we are already preparing for these eventualities, with innovative technologies and global collaborations aiming to monitor, predict, and manage the effects of cosmic radiation. Ground-based observatories, alongside space missions equipped with specialized detectors, are constantly scanning the skies for changes in radiation levels, offering essential early warnings. These efforts not only protect astronauts and infrastructure, but also expand our comprehension of the energetic forces that govern the universe. As we consider the implications of these radiation spikes on our lives and technologies, the vast interconnectedness of our world with the cosmos becomes ever clearer. And speaking of connection, there's a fascinating phenomenon drawing our attention next, one that has baffled and inspired scientists for decades. It's time to explore the mysterious and fleeting whispers from deep space known as strange signals and uncover what they might be trying to tell us. As the next chapter of our cosmic journey unfolds, we tune into one of the greatest mysteries emanating from the vast expanse of the universe: strange signals from space. Imagine this: fleeting bursts of energy traveling for billions of years across interstellar distances, only to reach our planet as a brief whisper barely measurable by our most advanced instruments. These are fast radio bursts, or as scientists call them, one of the most puzzling phenomena in modern astronomy. While they last merely milliseconds, their impact on our understanding of the cosmos could last a lifetime. What makes these bursts so extraordinary is the sheer energy they release. A single burst can emit more energy than the sun produces in an entire day. And yet, their origins remain shrouded in mystery. One possibility is that these signals are the result of extreme cosmic events, such as the collapse of a neutron star or the interactions of powerful magnetic fields surrounding celestial objects. Some theories even hint at the involvement of black holes, with their gravitational forces capable of producing such intense bursts. But these explanations are just pieces of a much larger puzzle. Could there be other explanations, perhaps even involving advanced extraterrestrial civilizations using these signals to communicate across the stars? It is this tantalizing unknown that fuels both scientific curiosity and public imagination. Among these enigmatic detections, one signal stands out: the famous WOW signal, recorded back in 1977. Lasting 72 seconds, this signal was so precise and intense that it immediately captured the attention of astronomers. Its origin remains untraced, adding to its allure and leading some to speculate it could have been a message from intelligent life. However, no similar signal has been detected since, leaving us with more questions than answers. These signals are more than just curiosity. They represent a valuable opportunity for exploration. Scientists are now deploying arrays of highly sensitive radio telescopes, scanning the skies in search of patterns or repeated bursts that could unlock their secrets. The ongoing discovery of these signals has spurred international collaborations and innovative technologies, bringing together some of the brightest minds in the field. Through these efforts, we are slowly piecing together the story of fast radio bursts and other signals, transforming what was once an astronomical oddity into a fertile ground for groundbreaking research. From the possibility of cosmic collisions to the faint hope of finding life beyond Earth, strange signals from space challenge us to expand the boundaries of what we know and what we believe is possible. But the universe is not done surprising us yet. As we move forward, let us shine a light on a different kind of celestial mystery, one that might go unnoticed but holds the power to forever alter our view of the cosmos. With our gaze now shifting closer to home, let us examine a looming challenge that could significantly reshape our use of outer space: the increasing risk of artificial satellite collisions. As humanity continues to launch hundreds of satellites every year to power technologies like communication, navigation, and Earth observation, the space around our planet is becoming increasingly congested. Today, there are thousands of operational satellites orbiting the Earth, alongside countless fragments of debris left behind by defunct spacecraft, discarded rocket parts, and previous collisions. This growing crowd in Earth's orbit has caused scientists to warn of a troubling phenomenon known as the Kessler syndrome. The Kessler syndrome describes a scenario where a single collision between satellites triggers a chain reaction, creating a cloud of debris that damages other satellites, which in turn generates even more debris. This cascading effect could potentially make certain orbits, especially those critical for communication and weather data, completely unusable for decades. The implications of such an event are far-reaching, affecting not only the technology-dependent systems we rely on daily, but also future space exploration efforts. Imagine losing global positioning systems, satellite television, and even vital Earth monitoring systems overnight. This is the level of risk we are facing. One of the most recent and alarming reminders of this risk occurred when two satellites, one operational and one defunct, narrowly avoided collision in 2020. Incidents like this underscore how close we are to tipping the balance in our orbital environment. To mitigate this risk, space agencies and private companies are collaborating on solutions. Ideas range from better tracking and coordination to avoid collisions, to ambitious concepts like using cleaning satellites, equipped with nets or robotic arms to remove debris from orbit. However, implementing these strategies is no small feat, requiring considerable investment and international cooperation to succeed. As we continue to push the boundaries of space technology and exploration, the challenge of managing Earth's orbital environment becomes increasingly urgent. The race is on to ensure that our skies remain not only functional but safe for future generations. The importance of addressing this issue cannot be overstated, as the consequences of inaction could reverberate far beyond the surface of our planet. But even as we grapple with the challenges of our crowded orbit, the cosmos has more to reveal. Let us set our sights on another remarkable frontier, one that promises to expand our view of the universe itself. With the next phase of our journey in sight, let's delve into how advancements in telescope technology are pushing the boundaries of our cosmic vision. The universe has always been vast beyond comprehension, but until recently, our ability to observe its farthest reaches was limited by the tools at our disposal. Enter groundbreaking instruments like the James Webb Space Telescope, which represent a monumental leap forward in our quest to explore the unknown. Unlike its predecessors, this advanced telescope operates primarily in infrared wavelengths, allowing it to peer through cosmic dust clouds that once veiled the mysteries of distant galaxies and star-forming regions. Thanks to its unparalleled capabilities, scientists can now observe celestial objects that existed billions of years ago, shedding light on what the universe looked like shortly after the Big Bang. For instance, this remarkable telescope has already identified some of the earliest galaxies, unveiling formations from a time when the cosmos was just a fraction of its current age. These discoveries are not just about looking further, but also about expanding our understanding of how galaxies evolve, how stars are born, and even how planetary systems like our own may have formed. The implications of this technological leap are profound. By effectively expanding the observable universe, instruments like the James Webb Space Telescope are offering humanity a chance to rewrite some of the foundational chapters of cosmic history. They enable us to study phenomena that were once purely theoretical, such as the mysterious formation of the first stars or the intricate dance of galaxies merging millions of light-years away. This helps astronomers piece together the grand puzzle of how the universe has evolved over the eons. But the journey doesn't stop here. Scientists are already designing the next generation of telescopes, equipped with even more powerful lenses and broader spectrums of detection. These future instruments, likely to be launched in the coming decades, promise to probe even deeper, possibly uncovering clues about the elusive dark matter and dark energy that make up most of the universe. As we broaden our observational horizons, we are not just pushing the limits of our technology, but venturing into new realms of discovery that redefine our place in the cosmos. Such advancements remind us that the story of the universe is far from fully written, and with each step forward, we unlock a little more of its timeless secrets. Speaking of secrets, let's now turn our attention to a phenomenon that is as mysterious as it is fleeting, offering a glimpse into some of the universe's most extreme energies. Now shifting our gaze closer to home, let's explore an astonishing phenomenon that many might not even realize is possible: our planet occasionally capturing small asteroids, turning them into temporary moons. These cosmic hitchhikers, known as mini-moons, are tiny celestial objects that get ensnared by Earth's gravitational pull for a brief period before continuing their journey through space. While these temporary companions are much smaller than our familiar moon, they hold a unique charm and scientific value. Imagine an asteroid quietly entering Earth's gravitational grasp, orbiting us for a few weeks, months, or even years before being flung back out into the vastness of space. It's an extraordinary dance governed by the delicate balance of gravitational forces. Detecting a mini-moon is no small feat. Their limited size and transient nature make them difficult to spot without sophisticated tools and keen observation. However, astronomers rely on advanced telescopes and precise tracking systems to identify their faint movements against the backdrop of distant stars. Once identified, these mini-moons offer a rare opportunity to study objects that have ventured from the asteroid belt or even further, carrying with them clues about the early solar system. Such discoveries not only deepen our understanding of Earth's gravitational influence, but also provide valuable insights into the dynamic interactions between our planet and near-Earth objects. What makes mini-moons particularly intriguing is their potential for exploration. These small, temporary satellites are accessible targets for future space missions. Scientists envision sending robotic probes to study them up close, analyzing their composition to uncover secrets about their origin and the processes that shaped them. In the future, these mini-moons might even serve as testbeds for technology needed to intercept larger, potentially hazardous asteroids. Their brief visits to our orbital neighborhood remind us that Earth is not an isolated world but part of a dynamic, interconnected cosmic system. And as we uncover more about these fleeting companions, we are constantly reminded of the intricate gravitational choreography that governs the solar system. Now, let us turn our attention to a spectacle that paints the night sky with radiant colors, often reaching places where it has never been witnessed before. As we venture into the next phenomenon, let's illuminate the skies with a breathtaking natural display, the aurora borealis, also known as the northern lights. Typically confined to the polar regions, these shimmering waves of light are now predicted to dazzle spectators at much lower latitudes than ever before, thanks to increased solar activity. Imagine looking up from a region far from the Arctic Circle, perhaps in areas that have never witnessed this spectacle, only to find the night sky suddenly alive with vibrant hues of green, purple, and pink. This isn't just a dream, but a scientifically grounded possibility tied to the sun's dynamic behavior. Auroras are the awe-inspiring result of the interaction between charged particles from the sun and Earth's magnetic field. When the sun emits a powerful burst of energy known as a solar flare or coronal mass ejection, a flood of these charged particles is hurled toward Earth. As they collide with atoms and molecules in the upper atmosphere, they release energy in the form of light, creating the mesmerizing patterns we see as the northern lights. The intensity and reach of these displays depend heavily on the strength of the solar activity and Earth's magnetic field at the time. So why might this incredible display extend to unprecedented latitudes? Scientists predict a surge in solar activity during the current solar cycle, which peaks approximately every 11 years. This heightened activity could cause geomagnetic storms strong enough to push the auroral oval. the region where these lights are visible closer to the equator. Historical accounts reveal similar events, including one in the mid-19th century when the northern lights were visible as far south as the Caribbean. Modern technology and forecasting tools now make it possible to anticipate such occurrences with greater accuracy, offering the chance for millions of people outside the usual viewing zones to experience this phenomenon firsthand. The potential arrival of auroras at unexpected locations is more than just a visual delight. It's also a reminder of the sun's immense power and its influence on our planet. These events provide scientists with valuable opportunities to study the Sun-Earth connection, including insights into space weather, which can affect satellites, power grids, and communication systems. For skywatchers, the prospect of seeing an aurora in their own backyard is both thrilling and humbling, a cosmic reminder of the unseen forces at play in our universe. And now, as we continue our cosmic journey, let's explore the mysteries lurking beyond our solar system, where interstellar visitors may one day spark even greater intrigue. Now turning to the next cosmic marvel, let's venture into the fascinating realm of interstellar visitors, celestial objects that originate from distant star systems and occasionally journey through our solar neighborhood. One of the most intriguing examples of such a visitor was discovered in 2017 and named Oumuamua, a Hawaiian term meaning scout or messenger from afar. This mysterious object captured the imagination of astronomers and the public alike, as it became the first confirmed interstellar object to be observed passing through our solar system. Unlike anything seen before, its highly elongated shape, unusual trajectory, and lack of a visible tail left scientists puzzled over its true nature, sparking debates and theories that ranged from natural phenomena to even speculative ideas about extraterrestrial technology. The arrival of Oumuamua was more than a fleeting cosmic event. It was a wake-up call that our solar system is not an isolated domain but a crossroads for visitors from other parts of the galaxy. The detection of this object was made possible thanks to advanced telescopes like the Panoramic Survey Telescope and Rapid Response System in Hawaii, which are designed to scan the skies for fast-moving objects. Since Oumuamua's departure, scientists have been refining their observational techniques in anticipation of the next interstellar arrival. And indeed, their efforts paid off when, in 2019, another visitor named Borisov was discovered, marking the second confirmed interstellar object. Unlike Oumuamua, Borisov resembled a typical comet with a clear tail of gas and dust trailing behind it, providing researchers with a tangible opportunity to study the chemical composition of material from another star system. But what makes these interstellar objects so fascinating is the wealth of mysteries they bring along. Are they fragments of distant planets or stars? Could they hold clues to the origins of planetary systems or even the building blocks of life itself? By analyzing their trajectories, speeds, and compositions, scientists hope to uncover answers to these profound questions. For instance, Oumuamua's peculiar motion, seemingly influenced by forces other than gravity, raised the possibility it might be composed of unusual materials such as hydrogen ice or propelled by outgassing too faint to observe directly. Such discoveries challenge our understanding of how objects behave in the vacuum of deep space, pushing the boundaries of current scientific knowledge. The likelihood of encountering future interstellar visitors is higher than ever, thanks to advancements in detection technology and international collaborations in astronomy. Upcoming observatories like the Vera C. Rubin Observatory, with its powerful wide-field survey capabilities, promise to significantly enhance our ability to spot these elusive travelers. As we refine our tools and methods, the hope is not just to observe and catalog interstellar objects, but to one day send probes or missions to study them up close. Such an endeavor could yield groundbreaking insights into the materials and conditions of far-off star systems, connecting us more deeply to the broader cosmic environment. The study of interstellar objects is not just a scientific pursuit, it's a humbling reminder of the endless possibilities the universe holds. With each new visitor, we gain a fleeting glimpse into the distant corners of the galaxy, a tantalizing hint of the intricate cosmic web that binds us all. As we wait for the next celestial messenger to grace our cosmic doorstep, we are left to ponder the profound interconnectedness of all things in the universe. With this in mind, let us set our sights on the next chapter of our journey, where we'll witness the birth of stars and uncover the secrets of stellar creation. With the next phase of our cosmic exploration now in view, we turn our gaze to one of the most captivating phenomena in the universe, the birth of stars. Imagine witnessing a star emerging from a vast, dense molecular cloud, a birthplace of light and energy in the cold and dark depths of space. These regions, known as stellar nurseries, are filled with gas and dust that, under the force of gravity, begin to collapse and heat up, ultimately igniting into a newborn star. This process, which unfolds over millions of years, is a cornerstone of our understanding of how celestial systems come into being. For astronomers, observing starbirth in real time is no small feat. These events occur in distant regions of the galaxy and are often shrouded by thick clouds of cosmic material that block visible light. To overcome this, scientists rely on advanced instruments like infrared telescopes, which can peer through the dust to reveal the hidden activity within. Facilities such as the James Webb Space Telescope have been revolutionary in this regard, offering unprecedented clarity and detail of these stellar cradles. By studying the heat signatures and movements within these clouds, astronomers can trace the gradual transformation from a chaotic mass of gas into a structured celestial body. The importance of observing starbirth lies in its ability to answer fundamental questions about our universe. How do stars form? What determines their size and lifespan? How do they interact with their surroundings to shape galaxies? Each observation provides vital clues, piecing together the puzzle of stellar evolution. For instance, by studying protostars, those in their earliest formative stages, scientists gain insights into the initial conditions that influence a star's characteristics, such as its brightness, temperature, and potential for hosting planets. What makes this endeavor even more exciting is the role of cutting-edge technology in capturing these events. Instruments capable of detecting minute changes in gas density, temperature, and motion are giving scientists the tools to observe details that were once thought impossible. Additionally, computer simulations based on these observations allow researchers to recreate and predict the star formation process, refining our models of how the cosmos evolves over time. As we continue to enhance our observational capabilities, the prospect of studying starbirth in greater detail offers endless possibilities. These discoveries not only illuminate the origins of stars, but also deepen our understanding of the life cycles of galaxies. Every new star that graces our telescopes is a reminder of the dynamic processes that keep the universe alive and ever-changing. With this glimpse into the origins of light itself, we prepare to dive even deeper into the boundless mysteries of the cosmos. Now turning to an extraordinary topic that connects the mysteries of the cosmos directly to our planet, let's explore the phenomenon of galactic cosmic dust arriving on Earth. This tiny, almost weightless material travels across unimaginable distances in space, carrying with it the secrets of ancient stars, distant galaxies, and interstellar environments. Composed of microscopic particles of metals, minerals, and frozen gases, galactic cosmic dust serves as nature's time capsule, offering scientists a rare glimpse into regions of the universe that are otherwise unreachable. When this dust reaches Earth, often through meteorites or by simply drifting into our atmosphere, it becomes a treasure trove for researchers. These particles are incredibly resilient, surviving the harsh conditions of space and the fiery entry through our atmosphere. Once collected, they are carefully analyzed in laboratories where their composition tells the story of their origin. For example, some particles have been linked to supernova explosions, providing direct evidence of the life cycles of stars. Others have shown traces of organic molecules, igniting discussions about the building blocks of life potentially traveling across galaxies. One of the most groundbreaking studies of cosmic dust involves the Stardust mission. This spacecraft was launched to collect particles from the coma of a comet, a region rich in cosmic material. The samples it returned were a revelation, containing minerals that formed in the intense heat of stellar environments billions of years ago before cooling in the vast, cold reaches of interstellar space. By analyzing these particles, scientists have gained insights not only into our solar system's formation, but also into processes that shaped the galaxy itself. The arrival of galactic cosmic dust is not limited to isolated events. Every day, Earth is showered with hundreds of tons of this material, often in quantities too small to notice. Specialized collectors, such as high-altitude balloon experiments and Antarctic ice core studies, capture these particles for further examination. Each speck adds a piece to the cosmic puzzle, revealing information about distant regions of the galaxy, including chemical elements that are rare or even absent on Earth. What makes these discoveries particularly fascinating is their broad scientific significance. Cosmic dust not only helps unravel the history of star formation and galactic evolution, but also offers clues about the potential for life elsewhere in the universe. It acts as a messenger from the farthest corners of space, bridging the vast distances between galaxies and our tiny blue planet. As technology advances, the ability to analyze smaller and more complex particles will undoubtedly open new windows into the structure of the cosmos, bringing us closer to understanding our place in the universe. With every grain of dust that falls to Earth, the universe reaches out to tell its story. And as we marvel at these extraordinary celestial messengers, we prepare to venture deeper into the mysteries of space, where the next chapter of cosmic discovery unfolds before us. As we journey further into the vast stretches of our solar system, an exciting possibility emerges: the discovery of yet another dwarf planet in the distant, icy realms beyond Neptune. These celestial objects, like Pluto and Eris, belong to a fascinating class of bodies that have reshaped our understanding of planetary science. While they may be small compared to the 8 major planets, dwarf planets hold clues about the early days of the solar system, preserving materials and conditions from billions of years ago. Their study offers a unique window into the processes that gave rise to the planets we know today. Current exploration efforts are focused on 2 of the most enigmatic regions in our solar system, the Kuiper Belt and the Oort Cloud. The Kuiper Belt, a vast ring of icy bodies encircling the Sun just beyond Neptune's orbit, has already introduced us to wonders like Haumea and Makemake, each with its own unique story. Haumea, for instance, has an unusual elongated shape and spins incredibly fast, while Makemake is known for its reddish hue and the possibility of a tenuous atmosphere. Scientists believe that this region still holds many more secrets, with hundreds, perhaps thousands, of dwarf planets waiting to be discovered. Even farther away lies the Oort Cloud, an immense and largely theoretical sphere of icy objects that is believed to envelop the solar system. Unlike the relatively well-charted Kuiper Belt, the Oort Cloud remains largely unobserved due to its extreme distance from the Sun. However, astronomers predict that this far-flung region could host an abundance of dwarf planets, some so distant that their orbits take millions of years to complete. The detection of these objects requires increasingly advanced technologies, such as next-generation telescopes capable of capturing faint light from these remote corners of space. One of the most intriguing aspects of discovering new dwarf planets is their potential to redefine the boundaries of our solar system. Observations of these objects often reveal unexpected details, such as the presence of moons, rings, or even atmospheres, which challenge our assumptions and expand our understanding of planetary diversity. For example, when Eris was discovered, its size and mass led to the reclassification of Pluto, sparking a global debate about what it means to be a planet. Each new discovery carries the promise of similarly groundbreaking revelations. The search for new dwarf planets also plays a critical role in advancing our exploration capabilities. Missions like New Horizons, which provided the first close-up images of Pluto and its moons, have paved the way for future journeys into the Kuiper belt. Meanwhile, ground-based observatories and space telescopes continue to refine their techniques, scanning the skies for signs of distant objects. These efforts not only enhance our map of the solar system, but also extend our reach into the greater cosmic neighborhood. As we anticipate the moment when a new dwarf planet is revealed, we are reminded of how much remains to be explored in our celestial backyard. Each discovery is more than just a new entry in the catalog of solar system bodies. It is a step closer to understanding the origins and evolution of our cosmic home. With every telescope and spacecraft pointed toward the edges of the solar system, the potential for groundbreaking discoveries grows, promising a future where the mysteries of the Kuiper belt and Oort cloud are brought to light. And as we stand on the cusp of these discoveries, we find ourselves ever more connected to the intricate dance of worlds that orbit the Sun. With the next phase of the journey in sight, let us turn our attention to the spectacular phenomenon of enhanced meteor storms, a dazzling display that has captivated humanity for generations. Meteor showers occur when Earth passes through the debris trails left behind by comets or, in some cases, asteroids. These tiny fragments, often no larger than a grain of sand, ignite as they enter our atmosphere at incredible speeds, creating brilliant streaks of light across the night sky. While some meteor showers produce only a handful of meteors per hour, enhanced meteor storms stand out for their extraordinary rates of activity, sometimes producing hundreds or even thousands of meteors visible in just 1 hour. Such events are rare but unforgettable, offering a celestial performance that leaves even seasoned astronomers in awe. The mechanisms behind these enhanced storms lie in the density and composition of the debris stream Earth encounters. When our planet passes through a particularly dense cluster of particles or crosses paths with the fresh trail of a recently active comet, the result is a dramatic uptick in meteor activity. These storms are often associated with specific showers like the Leonids, which have historically produced some of the most intense displays ever recorded. For instance, during the Leonid storms of the 1800s, observers reported seeing so many meteors that the sky appeared to be raining stars. Modern predictions rely on detailed models of cometary orbits and debris trails to anticipate when such storms might occur, allowing scientists and skywatchers to prepare for these breathtaking events. Enhanced meteor storms not only captivate the public but also offer scientists a unique opportunity to study the composition of cometary materials and their interaction with Earth's atmosphere. By analyzing the light produced during these fiery entries, researchers can identify the elements and compounds present in the meteors, gaining insights into the building blocks of the solar system. Additionally, these storms serve as a natural laboratory for studying atmospheric phenomena, as the entry of a high volume of particles can temporarily disrupt ionospheric conditions, affecting radio communication and other technologies. For casual skywatchers, enhanced meteor storms are a reminder of the beauty and unpredictability of the cosmos. They require no specialized equipment to enjoy, just a clear, dark sky and a sense of wonder. Whether viewed from a quiet rural area or a bustling city with reduced light pollution, these events bring people together, inspiring a shared appreciation for the universe and our place within it. And for those hoping to witness such a celestial show in the near future, upcoming predictions suggest that showers like the Perseids, Geminids, and Leonids may delight audiences with higher than usual activity in the years to come. As we look forward to the next wave of brilliant meteor storms, we are reminded of the dynamic and ever-changing nature of the cosmos. These celestial displays not only connect us to the ancient past when early humans gazed up at the same spectacular sights, but also spur our curiosity to explore beyond Earth's boundaries. Moving ahead, the promise of another cosmic wonder awaits, offering yet another glimpse into the infinite possibilities of the universe. With humanity's eyes fixed firmly on the horizon of possibility, we now turn our attention to a groundbreaking chapter in our cosmic story, milestones in space travel that promise to reshape our relationship with the universe. These upcoming endeavors are not just about reaching new destinations, they represent a bold leap forward in technology, collaboration, and our understanding of what it means to explore the cosmos. Among the most highly anticipated milestones is the launch of crewed missions to Mars, a dream that has fueled the imagination of scientists and visionaries for decades. These missions aim to establish humanity's first foothold on another planet, transforming science fiction into reality. From advanced spacecraft designs to innovative life support systems, the sheer engineering ingenuity behind these efforts is a testament to human resilience and ingenuity. Equally exciting is the progress in deep space exploration, where spacecraft are being designed to venture farther than ever before. Initiatives such as probes to the icy moons of Jupiter and Saturn, rumored to potentially harbor subsurface oceans, could bring us closer to answering one of humanity's oldest questions: are we alone in the universe? These explorations are not just scientific missions but also profound philosophical quests, pushing the boundaries of what we know and opening the door to entirely new realms of understanding. Additionally, private space companies are playing an increasingly pivotal role in space travel. Their involvement not only accelerates innovation but also broadens access to space, making the idea of humans becoming a multi-planetary species more than just a distant dream. With plans for lunar bases, asteroid mining, and even commercial space tourism, these companies are transforming how we envision our future in space. For instance, the prospect of using resources from asteroids to fuel further exploration could mark a turning point, reducing our dependence on Earth's limited resources and enabling sustainable cosmic ventures. These milestones extend beyond the scientific and technological realms. They carry profound implications for humanity's collective spirit. The cooperative efforts required for such monumental achievements unite nations, fostering a sense of global accomplishment and shared purpose. Moreover, the discoveries and innovations born from these missions often have ripple effects on Earth, from advancements in materials science and medicine to inspiring the next generation of thinkers and dreamers. As we prepare to witness these historic milestones, it is clear that space travel is more than an exploration of distant worlds. It is a journey into the very essence of our potential. Each step forward reminds us of our ability to tackle the unknown with courage and curiosity, igniting a sense of wonder that transcends borders and generations. And as the next era of space travel unfolds, one can only marvel at the possibilities awaiting us among the stars. As we continue our cosmic journey, the next event brings us closer to the heart of scientific discovery, revealing the extraordinary mechanisms that power the universe itself. With the next phase of the journey in sight, we turn our attention to one of the most mesmerizing processes in the cosmos, the formation of an accretion disk. Imagine a swirling halo of gas, dust, and other matter spiraling around a massive celestial object, such as a black hole or a young star. This phenomenon, known as an accretion disk, is not only visually stunning but also a vital piece of the puzzle in understanding the mechanics of the universe. Accretion disks form when matter is drawn toward a massive object under the influence of gravity. As the material gets closer to the object, it accelerates and heats up, emitting intense radiation. This glowing spiral can often be observed from vast distances, providing astronomers with invaluable insights into the behavior of some of the universe's most extreme entities. Recent advancements in observatories and imaging technology have allowed scientists to predict and even directly observe accretion disks forming in real time. By studying these formations, researchers can unveil critical details about how matter behaves under immense gravitational forces. For example, near a black hole, the intense gravitational pull creates conditions so extreme that they approach the limits of our understanding of physics. The behavior of matter in these environments tests theories like Einstein's general relativity, pushing the boundaries of what we know about the fabric of spacetime. But the implications of observing an accretion disk extend beyond black holes. When young stars are in the process of forming, accretion disks play a crucial role in gathering and organizing the material that will eventually become planets. By investigating these disks, astronomers can gain a deeper understanding of how planetary systems, including our own solar system, come into existence. One of the most exciting aspects of studying accretion disks is their ability to act as cosmic laboratories, offering a window into the forces and processes that govern the universe on its grandest scales. These observations can reveal not only the physics of the objects themselves, but also how they influence their surrounding environments, such as creating powerful jets of energy that can stretch across galaxies. As technology continues to improve, the possibility of capturing ever more detailed views of these phenomena grows, further enriching our understanding of the universe. Peering into the heart of an accretion disk is akin to witnessing the universe in its most dynamic and transformative moments. These structures are both a source of wonder and a gateway to unveiling the fundamental laws that govern the cosmos. As we marvel at the extraordinary mechanics of these celestial objects, the stage is set for the final chapter of our cosmic journey, a step that takes us deep into the enigma of dark energy and the universe's accelerating expansion. With the final frontier of our cosmic exploration upon us, we delve into one of the most perplexing and fascinating enigmas of modern astrophysics: dark energy. Imagine an unseen force that permeates the fabric of the universe, driving galaxies apart and accelerating the expansion of the cosmos. This is dark energy, a phenomenon so mysterious that it challenges the very foundation of our understanding of physics. First theorized when astronomers discovered that the universe's expansion was speeding up rather than slowing down, dark energy accounts for roughly 70% of the universe, yet its nature remains largely unknown. Scientists predict that groundbreaking discoveries about dark energy could be on the horizon. Upcoming advancements in space telescopes and observational technology may allow researchers to measure the universe's expansion with unprecedented precision. By mapping the distribution of galaxies and studying how light from distant objects bends as it travels through space, astronomers hope to piece together the puzzle of what dark energy truly is and how it operates. This could radically transform our understanding of the cosmos, potentially revealing new laws of physics or hidden dimensions that lie beyond our current comprehension. Unlocking the secrets of dark energy may also provide profound insights into the ultimate fate of the universe. Will the cosmos continue to expand indefinitely, growing colder and darker as galaxies drift ever farther apart? Or could dark energy evolve in ways that lead to a dramatic end, such as a Big Rip scenario where the very fabric of space-time is torn apart? These questions are no longer confined to the realm of science fiction, but are active areas of research that could yield answers within our lifetime. The implications of unraveling dark energy are far-reaching, not only for understanding the universe but also for potential technological breakthroughs. By mastering the forces that shape the cosmos, humanity could one day harness new forms of energy or uncover principles that revolutionize space exploration and other scientific fields. As we stand on the cusp of these discoveries, one thing is clear: the universe still holds countless secrets waiting to be revealed. Dark energy is a reminder of how much we have yet to learn and how every answer leads to new questions. It is the ultimate frontier of curiosity, inviting us to keep looking deeper, asking harder questions, and marveling at the infinite complexity of existence. And with that, our cosmic journey through 25 extraordinary events draws to a close. But this is just the beginning. The universe awaits, filled with more mysteries and wonders than we can yet imagine. Which of these cosmic events sparked your imagination the most? Let us know in the comments and join us again for more explorations into the boundless cosmos. Don't forget to subscribe, like the video, and hit the notification bell to stay updated on our next adventure. Keep looking up. With the next step in our exploration, the potential impacts of uncovering the mysteries of dark energy come into focus. Understanding this enigmatic force isn't just about satisfying cosmic curiosity. It could revolutionize how we view and interact with the universe itself. For decades, our grasp of the cosmos has been built on well-established theories of gravity and the behavior of matter. But if we decode the essence of dark energy, those foundational principles might need a complete rewrite. Imagine a future where we uncover entirely new laws of physics, ones that alter our understanding of space, time, and energy. Such revelations could challenge long-held beliefs and lead to breakthroughs that redefine the boundaries of science, unlocking realms of knowledge we have yet to fathom. The practical possibilities stemming from this discovery could be equally staggering. By tapping into the mechanisms driving dark energy, humanity might one day develop technologies that defy the limits of our current capabilities. From advances in energy generation to new methods of propulsion for space travel, the implications are monumental. Such innovations could enable interstellar exploration on a scale that feels like science fiction today, bringing distant galaxies within reach during the lifetime of future generations. Beyond space exploration, the knowledge gained from studying dark energy might even pave the way for revolutionary applications here on Earth, including advancements in materials science, energy efficiency, and even medicine, as we learn to manipulate fundamental forces in ways never before imagined. Peering deeper, the societal and philosophical shifts could also be profound. If dark energy holds the key to understanding the ultimate fate of the universe, it challenges us to rethink humanity's place in the grand scheme of existence. How might our priorities as a species evolve if we grasp the full scope of the cosmos and the forces driving its destiny? This knowledge could inspire a greater sense of unity and purpose as we collectively confront questions about life, the universe, and everything in between. Yet, alongside these possibilities, unlocking the power of dark energy may also raise ethical and existential dilemmas. As with any significant leap in scientific understanding, we must consider the responsibility that comes with such power. How will we manage its use? Who will benefit from its potential applications? And how might it reshape global dynamics as nations and industries race to harness its capabilities? These are questions that underscore the importance of approaching such discoveries with both awe and caution. In short, the implications of understanding dark energy reach far beyond the stars, promising to reshape not only science but also the way humanity lives, thinks, and dreams. As we stand at this awe-inspiring crossroads, it is clearer than ever that the pursuit of cosmic knowledge is as much about our future as it is about the universe's past. The mysteries of dark energy may just hold the answers to questions we have yet to ask, reminding us that the journey to understanding is infinite, just like the cosmos itself. With the next phase of our journey into the cosmos, let us examine an event that strikes a balance between awe and unease, the potential impact of a comet colliding with Earth. Though such occurrences are rare, the devastation they could bring makes them a subject of both scientific scrutiny and global concern. Throughout Earth's history, the scars of past impacts serve as stark reminders of their might. Take the Chicxulub impact, for instance, which is widely believed to have caused the extinction of the dinosaurs around 66 million years ago. The energy from that collision was equivalent to billions of nuclear bombs, fundamentally altering Earth's climate and ecosystems in a matter of moments. Such events remind us of the cosmic forces at play and the delicate fragility of life on our planet. Today, scientists are far from passive observers when it comes to these celestial threats. Advancements in astronomical technology have led to the identification and monitoring of millions of comets and asteroids, with special attention given to those on paths that bring them close to Earth. These objects are part of what is known as near-Earth objects, and space agencies like NASA and the European Space Agency have developed sophisticated systems to track their trajectories with remarkable precision. The goal is simple: detect potential threats early enough to respond effectively. The Planetary Defense Coordination Office, for example, continuously scans the skies for anything that poses a risk, providing humanity with its first line of defense against an uninvited cosmic collision. But detection is only part of the equation. The real challenge lies in the response, and that's where science fiction begins to resemble reality. Efforts are underway to develop methods for deflecting or disrupting potentially hazardous objects before they reach Earth. One such approach is known as the kinetic impactor technique, which involves sending a spacecraft to collide with the threatening object, altering its course just enough to avoid disaster. In fact, this technology recently saw a successful test with the Double Asteroid Redirection Test mission, where a spacecraft was deliberately crashed into an asteroid to demonstrate our growing ability to manipulate these celestial wanderers. Beyond impact deflection, future strategies may include more advanced solutions such as gravitational tugs, where a spacecraft uses its own gravitational pull to nudge the object off its deadly trajectory. However, the global response to a potential comet impact must extend beyond technology. It requires international cooperation, as the consequences of a major celestial collision would be felt worldwide. Governments, space agencies, and research institutions are increasingly collaborating to improve our collective readiness, sharing data and resources to ensure no stone or space rock is left unmonitored. Simulations and emergency response plans have even been developed to guide how humanity might act in the face of such an event, emphasizing the importance of preparation even for scenarios that may seem far-fetched. While the probability of a significant comet impact in our lifetime remains low, the stakes are simply too high to ignore. These efforts remind us of the interconnectedness of our world and the resilience of human ingenuity when faced with an existential threat. It is a sobering yet inspiring thought. As we gaze up at the stars in wonder, we also remain vigilant, ready to protect the precious planet we call home. Let's keep this balance of curiosity and caution in mind as we move forward to explore yet another celestial phenomenon shaping our understanding of the universe. As our journey through the cosmos continues, let us now delve into one of the most powerful and transformative events in the universe, supernova and their remnants. When a massive star reaches the end of its life, it explodes in a spectacular display of energy, leaving behind a remnant that carries the echoes of its fiery demise. These remnants are not just debris scattered aimlessly through space. They are cosmic forges where the elements necessary for life itself are created. In fact, many of the heavy elements we find on Earth, such as gold, silver, and even the iron in our blood, were formed in the intense heat and pressure of supernova explosions. When a supernova occurs, the energy it releases can briefly outshine an entire galaxy, spreading its enriched contents across vast distances. These elements then become part of interstellar clouds, which someday may coalesce to form new stars, planets, and even life. In this way, supernova remnants are not endpoints but rather beginnings, seeding the universe with the building blocks of existence. Astrophysicists study these remnants closely, as they provide a unique glimpse into the life cycle of stars and the intricate processes that shape the cosmos. Observatories equipped with advanced technology such as X-ray and radio telescopes track these remnants to understand how they interact with their surroundings, offering insights into the chemistry of the universe. However, the effects of supernova extend far beyond their immediate surroundings. The shockwaves generated by these explosions can compress nearby molecular clouds, triggering the birth of new stars in a dramatic process known as triggered star formation. Yet, while supernova can give rise to new celestial structures, they can also disrupt the stability of neighboring star systems. Radiation from a nearby supernova, for instance, could strip atmospheres from planets, rendering them uninhabitable. Our own solar system is not immune to such possibilities. Studies suggest that past supernova may have influenced Earth's climate and even played a role in mass extinction events. Though rare, the impact of these cosmic detonations serves as a reminder of the interconnectedness of all matter in the universe. Interestingly, the remnants of supernova also hold clues to the mysterious regions known as neutron stars and black holes. These remnants represent the collapsed cores of massive stars and are among the densest objects in existence. By studying them, scientists unravel the physics of extreme environments, shedding light on phenomena that challenge our understanding of the universe's fundamental laws. Some remnants, such as pulsars, emit beams of radiation that act like cosmic lighthouses, offering precise markers for measuring distances in the galaxy. Supernova remnants are not just remnants of destruction, they are catalysts for creation, agents of both chaos and renewal. They remind us of the delicate balance that governs the universe, where endings pave the way for new beginnings. As we continue to grapple with the mysteries they hold, we expand our understanding of the universe and our place within it. With this in mind, let us venture further into the cosmos to uncover even more awe-inspiring phenomena that reveal the dynamic and ever-changing nature of our universe. With the next phase of the journey in sight, let us now explore one of the most exciting frontiers in modern astronomy, the analysis of exoplanetary atmospheres. Exoplanets, or planets that orbit stars beyond our solar system, have captivated scientists and enthusiasts alike. But what truly elevates this field is the growing ability to peer into the atmospheres of these distant worlds to search for biosignatures, key indicators of life as we know it. By using advanced techniques and state-of-the-art telescopes, scientists are now able to detect specific gases such as water vapor, methane, and oxygen in the thin atmospheric layers surrounding these far-off planets. Each of these compounds holds unique potential clues. For instance, water vapor suggests the presence of liquid water, a fundamental ingredient for life as we understand it. Methane, especially when paired with oxygen, could indicate biological activity, as many forms of life on Earth produce these gases in tandem. The process of analyzing exoplanetary atmospheres begins when a planet passes in front of its host star. As starlight filters through the planet's atmosphere, its chemical composition imprints distinct patterns onto the light, much like a fingerprint. This phenomenon, known as transmission spectroscopy, allows astronomers to decode these patterns to determine the presence of specific molecules. Instruments aboard powerful telescopes, such as the James Webb Space Telescope, have recently made remarkable breakthroughs in this area, enabling us to study smaller, Earth-like planets in unprecedented detail. Once detected, these molecules are analyzed to assess their potential origin. While some gases, like carbon dioxide, can result from geological processes, others, such as an abundance of oxygen mixed with methane, might hint at ongoing biological activity. However, interpreting these findings is far from straightforward. Not all biosignatures are definitive signs of life, as non-biological processes can also produce many of the same gases. For example, volcanic eruptions or other natural mechanisms might mimic what we associate with living systems. Therefore, scientists must rely on a combination of factors, such as the planet's temperature, pressure, and distance from its star, to build a comprehensive picture of its habitability. This careful analysis helps separate false positives from genuine indicators of life. Beyond the search for extraterrestrial life, studying the atmospheres of exoplanets also expands our understanding of planetary evolution and climate dynamics. These insights could one day inform efforts to make Earth more sustainable or aid in creating livable conditions on planets like Mars. Imagine the profound implications if we were to find a planet with an atmospheric composition strikingly similar to Earth's, a potential second home or evidence that we are not alone in the universe. The search for biosignatures is not simply about finding life. It is about redefining our place in the cosmos and deepening our understanding of the universal conditions that make life possible. This ongoing research reminds us that every question answered brings with it new mysteries to unravel, keeping the scientific journey as boundless as the universe itself. Moving forward, let us turn our attention to another compelling endeavor in the study of distant worlds, examining the slow-motion cosmic dance between our galaxy and its nearest celestial neighbor. As our journey through these 25 extraordinary cosmic events draws to a close, let us take a moment to reflect on the boundless wonders of the universe that continue to captivate our imagination. From the electrifying potential of a solar superstorm to the profound mystery of dark energy, and from the discovery of rogue planets to the spectacular merging of black holes, each event reminds us of the vast, intricate, and awe-inspiring cosmos that surrounds us. These occurrences are not just distant phenomena, they are a testament to the relentless curiosity that drives humanity to explore, to question, and to understand our place in this infinite expanse. Every prediction opens a doorway to new discoveries, each more astonishing than the last, leaving us humbled yet eager to learn more. Which of these events sparks your curiosity the most? Is it the search for life among the stars, the thrilling near-miss of an asteroid, or perhaps the enigmatic signals that hint at the unknown? Share your thoughts in the comments below. We'd love to hear what excites you about the future of space exploration. Also, if you enjoyed this journey, make sure to subscribe to our channel for more cosmic adventures. Hit that notification bell so you never miss a moment, and give this video a like to show your support. Together, let us keep looking up, for the universe holds endless mysteries, and the next breakthrough might just change everything we know. Thank you for joining us, and until next time, stay curious and keep exploring.